welcome to the Public Health AI Collaborative Network. I'm Andrea King, and today we are going to hear from Jason Geslois, who's a senior epidemiologist at the Kansas Department of Health and Environment, where he provides epidemiological data support on multiple maternal and child health programs. He's an expert R user, and he's going to talk to us today about Agentic AI for our Shiny dashboard and package development. So, Jason, go ahead. Thank you.
Thanks, Andrea. Thanks, everybody. Let me get my, let's see. Okay, I think I sent the request to do the share screen, but so in the meantime, I appreciate you guys for having me today. I always enjoy talking to the group. Let's see now. Okay, does it show the full slides for everybody?
It
No, it
does.
just, it does. Okay. All right, so I'll go ahead and get started. All right, so hello everyone. I'm Jason Geslois, again, Senior Epidemiologist at Kansas Department of Health and Environment. And today I want to talk about a fairly new way of working with AI, and most of us in public health at least, but when we build tools in our Shiny. And so most of us have used a chatbot to ask a coding question. And what I want to show you is a step beyond that so that AI can actually work inside a project, write code, run it, see what happens, and fix its own mistakes. And that's what people mean by when they say agentic AI. And so the focus is specifically on Shiny app and package development, and I'll keep the examples related to the kind of dashboards that we build in public health. And so I've known these tools are useful, but they don't replace our judgment. And I'll show you exactly, where the human or person or user, and I'll use those interchangeably throughout, needs to really stay in charge of that. And so also, of course, AI was used in this presentation, but the use of fully autonomous AI agents weren't. And I'll explain more about what that means as we get into it. And so what we'll cover for today's presentation is, I want to define what makes an AI tool agentic. Kind of the core idea is a loop where the AI plans, acts, looks at the result, and corrects itself. Then I'll explain two mechanics that make that loop work. Tool use, meaning the AI can actually do things like run code and context, meaning, what the AI is able to see at any moment. And then after that, I'll talk more specifically about Shiny, why this same workflow fits Shiny development well, and where it can run into trouble. And we'll walk through three public health examples. They're sketches, so not really finished products, but they show the shape of the work. And we'll close with a look at the risks, where a person stays in the process, and then a few practical next steps forward. So let's start with a basic distinction because this is the thing that most people, often get confused about. And so we're going to separate the AI that you chat with from the AI that works alongside you in your project. And they can use the exact same underlying model, as the difference is what the tool is allowed to do on your behalf. So think about how you normally use an AI chat tool. You type a question, it gives you an answer or on a block of code, and then you are the one that copies that code, pastes it into RStudio, runs it, reads the error, and goes back to ask again. You're the messenger carrying information back and forth. And an agent closes the loop itself. So it works inside your project. It can open your files, write or change code, and run it. And crucially, it then reads the result of what it did and keeps going. So the model isn't necessarily smarter. It's been given hands, meaning the ability to act. For example, given eyes, the ability to see what happened. And that's the whole shift. One practical implication, because it acts on real files, you decide what it's allowed to touch and run. And so we'll come back to that in a second. So now there are two different things people mean by AI coding. The first is in the chat assisted process. A human is in the loop every step of the way. It follows a process, proposes an idea, solution, tests it, it reports back. The AI reports back. You iterate through each continued step. This is slower, but nothing is running that person or human can control, cannot stop, which is what's we're talking about overall today. An agentic is in the use of multi-step tool use, meaning by the AI on its own. And so the AI can run one or many agents to run the code, detect errors as it reads it, and then can self-correct as it finds them. It can run autonomously, without humans at each step, but it can still prompt back and ask the user for guidance. And so this process is much faster. And one of the examples of this, give you an example, is like using Claude Code or one of the Shiny Posit products. And so which we'll reference here again later in some of the other tools, but not run exactly on live here today. But this is kind of what we're talking about. So now this slide is a key piece in understanding our talk today, and I'll walk through it. Step one is in the plan. So like an agent would take your request, for example, you say add a county filter to this dashboard. Remember, the agent has access to your dashboard file, finds the code, looks where it needs to add it, and then breaks it into concrete steps. What file does it need? What has to change? Step two is the act. It does one step, it writes or edits the code or runs a command on the code as it needs to. And step three is observes. This is the part that makes it agentic. It looks at the actual result that it processed. Did the app start? Did R throw an error? What did the error say? And then step four is correct. So based on what really happened, not what it guessed would happen, it changes the code. And then it repeats the plan, act, observe, correct again and again until the task is done or decides it needs to ask you something. And so if you've ever, debugged by trial and error, this is the same rhythm, just faster. So it's doing the same type of process that we would normally do over our code in that same type of format. And so I'll explain a little bit more about the act and observe steps a bit more because this is where tool use comes in. So an AI tool, is simply an action that the agent is allowed to take beyond just producing text. For example, reading a file or editing a file or running R itself or launching the app, searching across the code base. So the way it works is that the model decides which tool it wants to use and with what input the tool runs for real. And then the model gets back the real result. So, instead of guessing what your data looks like, you can actually open the file and check. And then that what turns a suggestion into a working change. And so a chat tool can only tell you what to do. An agent with tools can do it and confirm it worked and again. And then you set the boundaries, of course. And then so most of these tools you approve which commands that it can run, especially anything that touches, real systems or real data. Now, the second mechanic is the context. So, this one matters a lot for reliability. The model can only reason about what's currently in front of it. So, what's called it's in its context window. It's a bit like short-term memory. There's a limit to how much it can hold at once. So, a good agent is selective. It pulls in the files that are relevant to your request, the error message it just got, maybe the documentation for a function, it leaves out the rest. As a task gets long, it has to summarize or set aside older details so it doesn't run out of room. And then when it manages that well, you get relevant information and the noise goes away. The takeaway here is that on a bigger project, the agent can't hold everything at once. And so how it chooses what to look at directly affects how good the answers are. And so clear file structure and good naming process helps it choose well. So given now that what we've talked about in terms of agents and what are some of the agentic tools briefly, these are functions similar to things like Claude Code, OpenAI Codex, GitHub Copilot, the ones like in the Posit products and things like that. And so they can run in your command line or terminal. They can have a dedicated app environment to work from. And so these are just some of the examples that you might run across. And there's a lot out there now these days to be able to use from. So when thinking about evaluating each of these tools or other tools, when you consider how they're different, and it's important to think about where the oversight fits in your overall workflow that you'll be giving it. For example, is it going to be on your local machine only? Is it going to be in the cloud? Will some of the tools need your input? What level of execution you give it over files to either just suggest changes or make the changes itself, and then how we review the final product. Is it something that needs to be done line by line or over the functionality and the result of that functionality? So those are types of things when you're evaluating, the fit of use of what these tools mean. And so, now that we've kind of talked about the loop and understand that loop process, let's talk about why Shiny in particular is a good match for it. And, there are real limits to it as well, which we'll touch on. So our Shiny apps have a, very particular structure and it works well with the agent loop process. So an app is really two connected parts. It's the UI, which is what the user sees, and the server logic, which is reactive, meaning the doing part of your code, like the chart, the table, etc. The outputs recompute automatically when their inputs change. And because everything is connected, a small change tends to ripple. And so you add an input that feeds a reactive expression, which feeds an output. And the agent has to reason about that chain. And so the helpful part is the feedback. So when you run a Shiny app, it either starts and renders or it fails with a fairly specific error. And so that quick run and see cycle is exactly what the observe step needs. And so, one practical tip is if you name your inputs and outputs clearly, the agent can trace and reactive chain much more reliably. And so, like vague names would make it guess. So thinking about some of like the debugging process and reactive bugs, and those are often ones that are silent and that are good fit for where an agent can help. So often, nothing might crash. If you change a filter or your table, just doesn't update, you might not see an error or just, maybe wrong or stale output. And so those are hard to chase down a lot of times by just reading the code alone. And so, the workflow is if you describe the wrong behavior in plain language, when I change the year, the chart doesn't refresh, the agent opens the server code and then would trace the reactive chain to find, where the dependency is broken. So, propose a fix, rerun the app, and check whether the behavior changed. It can also, add guardrails like, validate or the rec function so that if the app fails, it, can fail more gracefully and instead of just silently without you being able to see it through. But the last step is again yours. It's you confirm the fix that produces the numbers that the dashboard is actually supposed to show, meaning the agent can make it work and run, but only you know if it's right. So that's a key piece in understanding that. So, and as a lot of dashboards rarely break on tidy examples of data. They break on real data, meaning missing values, a column that's a character, when you expected a number, some other code that nobody documented. And the agentic workflow is to point out that the agent had a realistic looking sample data set and let it run. And that's what we do here. If you are just starting out, test it on fake data. As we all know, we don't hand protected, health information to these tools. Use a synthetic or fully de-identified fake extract that is similar. And so with that in mind, the agent runs the app, hits the real error, and adjusts the code. Handling the NA, coercing the type, correcting the edge case. Then you repeat it across different variables, counties, years, age groups. And once more, again, that's the user. Human sets the definition of what will be correct. And the agent can make the app stop erroring, but you decide whether, the rate is actually showing is the rate that we mean or is correctly expressed. So now for where agentic workflows can struggle and the problems that can arise is so that, is the visual layout capable of being used by someone with disabilities? An agent can build a working chart, but does this dashboard read clearly, for a busy program manager? Or, that's a human type question. It doesn't know the style you need or your audience that you may be working with. And so very complex reactivity can exceed the agent's mental model. And so when there are many interdependent reactives, it can lose the thread and make a change that fixes one path and breaks another. And so related to that, it sometimes fixes the symptom and not the cause. And so the error may go away, but the underlying logic of it is still wrong. And so apps that are long running or highly interactive, are hard to fully test automatically. And so it can't click through every combination the way that a user would. And so the big one is the domain correctness, case definitions, the right denominator, how you handle suppression of small cells. That's on us always. So, building a full functioning package will take time and, many iterations. And so, for example, in R, there's a utils package so that when we're making packages to check whether sources of your package, if they're building, will work correctly. And then each run after you would build it, this is where like an agent would build. After multiple passes, you can see the reduction of warnings and notes in the output that from the console. And this can be adjusted based on your feedback to the agent as well. So, in this example, after creating the package, it never had any errors during each subsequent pass, and what the package always ran when it loaded. But which makes sense, being that it was clean synthetic data, in a simpler design package from the start that I'll show you here. But you can see that after each one, the iterations changed based on what was displayed. Okay, so now we're going to go over so now we've already gone over what the agents are. How can they work within an R context? and you can go through some public health examples. And so in these examples, none of them require a finished, published product to think about, but this really can just kind of work through the examples and things that, you may be building or the iteration process throughout. So our first example, we'll be using the places data set. And it's a CDC public data set around various health related measures of chronic disease. And then in building the dashboard, you describe the goal and controls you want to the agent. A drop down for the disease or condition, a date range selector, and a county filter, the types of visuals you want to see, or the comparison that you may want to make. The AI agent scaffolds the UI for those controls, wires up the reactive expressions that filter the data and draws the plots, and using something like ggplot2 or plotly for an interactive trend. Then it iterates on various parts. For example, did it shade things correctly? Do things like prevalence percents line up with the right numbers? And your job at the end is verification. Pull the raw counts from one county and confirm everything matches the source tables. So if they do, you can then use this as a foundation to extend on or complete, any work you want to build on it from here. And our second example is a maternal and child health reporting dashboard for the Title V block grant measures. The good thing about some of these measures is that they are publicly available and already clean to work with for something like this, which is what an agent um, can handle well. You give it the measure specification, it builds the input forms until eventually you get clean formatted charts and filters that you specify. If you want to build in a data export feature, you can. Do you want a dark mode toggle, as seen here, then it can be done and told to incorporate. And since these measures are specified already, the only verification you need is to check each computed measure against the imported definitions. Does this rate use the right denominator? Are we counting the right population? The agent assembles it, you confirm it matches exactly. And the data shown on the display here is public from the National Vital Statistics System from 2021. And so this is a process that it takes working through the design in each of these. And then our third and last example is creating an actual package in R. So for example, this is one I created for their presentation called MCH Tools, which includes several functions that do various types of things related to similar structures in one of our databases that we use here in Maternal Child Health. Again, no actual data was used in or fed in to the AI, and this example was made for this presentation with fake data. And you can see the descriptions of some of the functions for what they do on the right-hand side there. But those are just listed out, the functions in it and the descriptions there. And just to give an example of what one of the functions looks like, so showing a kind of a before and after when using the split multi-value function, is that in this example, it'll take the combined domains, like from the first row of the left table, and then make them into separate rows, like the first two rows in the right table. And so this is a real type of data problem that you see when working in a variety of public health data sets. So this is just one example of when building tools like this to think about, how to handle and work on for various types of things that, you may actually work on in your data sets as well. And so, before we get to the end and do another demonstration, I want to highlight some areas for potential failure with agentic coding and some things to continue to look out for in your work. So here are some types of failures to watch out for in your code when you're actually going through the process of it. The first is hallucinated logic. So code that looks completely reasonable but is subtly wrong. Meaning, for example, it reads well, it actually runs, but it computes the wrong thing. And related to this, sometimes invent a function or an argument that simply doesn't exist, or it exists in a different package. And it sounds plausible, but that's where you have to be observant on its output. Another fail point is fixing the error message instead of the real problem. So, making the red text go away without addressing, why it appeared in the first place. So in your code will run and won't throw an error, but it'll still fail in what you actually intended it to do. Then there are silent assumptions about your data. It may assume a column means one thing when it actually might mean another. And the biggest risk, as you all know, is overtrust. Accepting output just because it ran without error, and it ran is not the same as it's correct. And so that distinction is critical, and you should always remain skeptical and verify, like I've been saying throughout. Now, this slide, and I won't go over the details on these specifics, but these were some of the things addressed when I was building the MCH tools package, and I mentioned about the warnings and the notes changing for each pass. Small elements of the code that you seemingly might miss, or let go undetected that as the human reviewer, would need to consider and think through to catch afterwards. Then you can work with the AI to better catch these in the future to improve the quality of your code output with it. So if the agent does a lot of the typing. What's left for us? Well, it's really quite a lot, and that's the important piece of really what today's talks about. So, we define the question and what a correct answer looks like. The agent can't tell you which measure matters or what counts as a case. If we provide data and its clear requirements, we need to instruct it carefully, just like we would if we were training, say, a new analyst hired. We reviewed the code and the numbers, not just the screenshots. A dashboard that looks polished can still be wrong underneath. We own the privacy, we own the security, and the public health interpretation. And so that responsibility does not transfer to a tool. And so we decide what it's good enough. We decide that when it's good enough to share. And so that judgment call still stays with us. So if you're interested in trying this, my first recommendation would be to start small, and of course, give an agency approval or appropriate accesses, etc. Pick one feature on an existing dashboard or even a small, simple one to build from. A single filter, one new chart, rather than attempting a full rebuild, and you'll learn the workflow without much at stake. Use a fake de-identified sample data set so you can test it safely. Write your instruction prompts to the AI as if you were teaching, a new analyst, what the input is, what the output should be, and how you'll know it's right. Clear requirements of the single biggest improvement on quality that you can do. Always run and read the code yourself uh, before you trust it, and treat the agent's output like a draft from an intern. Helpful, but you review it. You can also use version control, so you can experiment freely and undo anything with more confidence through the different iterations. So these are just some of the things that can help you lower the risk of using AI and agentic workflows. While doing some of the core work that we do towards improving public health. In addition, things like building skills, and really iterating and saving notes and things like that to improve the overall uh, long-term use of it to again work towards our overall process of improving public health and the people that we serve. So here's my contact information. And then this is the end of my actual presentation. And then I will give you a brief demo of the MCH tools section here really quick. So just to kind of give you an example of what it looked like. So again, in our studio, as our studio everybody's familiar with, I have it loaded in here, MCH tools. Actually, like it's loaded as a package created in here. Um, so we just run some code to see how it worked through that whole process going through. We load the tidyverse. Okay, we load MCH tools just like it is here. And actually we can click it and it gives you the full breakdown of, tells you what functions are, the descriptions. I want to know what the description is. It gives me the list of information about it, that type of thing. Just like any other package that we would do. We want to know what each one is. You can click it and you can see the information and it gives examples in your script here below like that. So now that we have it, so let's just give you a couple examples of what some of the functions and things are in it. For example, so let's, as we do a glimpse, is we want to look at data sets and things like that. Again, this MCH data is fake data created here for that, for this call. No real data is in it. And so one of the things that you might want to look at is then in terms of, when you're actually working with data, it has a function called short glimpse. And so when you glimpse it to actually see the structure, like the columns and the rows, you can see the columns here, the characters of some fake data. And, one of the things that in some other data sets we work with, they're really long column names. And so it makes it hard to, okay, do I need to manually adjust like this or whatnot? And so that was a going to be a frustration sometimes. So short glimpse is a function that shortens that. So you can see that you can widen those variables to see it a little bit easier without having to go in and actually tweak it down specifically. Um, and it gives you arguments so that if you can actually custom tailor it to like your data sets, you may be doing it over time more. So, given those arguments, I can consistently, open data sets like this if I don't need to actually see the whole long name of each column. Um, and you can do this if you're like copying, for some other thing like a report or, data quality report. You just need to look at a specific column name. You can do that and then shorten it specifically to go copy it later on, that type of thing. And again, so that was just the, example of some of the MCH, the fake data that's in here created for this today. But let's say you want to actually visualize some data, similarly to what that one slide had about the multi-values in lines, because several times there's data sets that have those delimiters that are split like that. So we just have using the split multi-value on that on the data on the column there, and just do a little bit of visual. Okay, we put some the plot measure trend function that's also in the package, and we get this nice, pretty ggplot, summarizing some of the data, looking at it over time, that type of thing with the breakdown. Um, and so it's built in there. We have a nice plot. We can split the values so that we can actually make it usable to actually show some type of interpretation in a bar chart. But let's say we want to look at it from a line chart version as well, and we can do the same thing. And so put split multi-value the argument, plot measure trend, and then we get a line chart doing the same type of thing. And so again, not the importance of this package in particular, but these are all the types of things that you can do and build when you're doing the work that you're doing to think about how can agents help build me the things that I need to solve the real world problems that I do in public health. And so these are the types of things that you can do when you really iterate through the agentic process and go through all the steps as you do. Um, and so with that, that's really, I think, everything I have to show for all. And I have some links that I can drop in the chat later. But yeah, well, thank you for having me, and I appreciate you guys. And I take questions.
Great, thank you. I'm like making notes over here for some things that I want to go check my code base for. Um, yeah, this is awesome. Let's open it up to questions. I see we had a couple in the chat. Brian, would you like to unmute and ask your question about documentation?
Sure, happy to, Andrea. Hey, yeah, thanks for the presentation. Yeah, my question was around documentation. As when you're creating your tools, did you ask the agentic, when you ask the AI to create the documentation, and how good is it? Because we've got legacy stuff laying around that past MPH interns and others have created, and then no one knows how to use it after they leave, and so I'm hoping maybe AI can create documentation as it's writing code so that future people can understand what the heck these functions are doing.
Yeah, so that's something definitely you can add into it as well. So you can have it where you outline specifics, like here's this, what this function means, and this goes toward answering this question or whatnot. And then it can go to, you can even have it explain in questions of like put this in the eighth grade reading level so it can be understood from a simple terms, or from a program manager that doesn't have a lot of data background, that where they can understand it when they're applying to a grant that is from that context. And so those are the types of things that you can think about when you're using it. So it doesn't, because a lot of times as, analysts, epidemiologists, we can get into the weeds of like the mechanical, technical side of it. But we get lost a lot of times in the simplicity of well, what does your everyday average user mean? And what does that mean towards that? And so that's actually a really good use case for it. And I didn't actually show that. That would have actually been an example, but that is very capable, a possibility easily done for sure. And you can actually go build it skills and things like that to go in where you can have it review, does this meet legal requirements, or does this meet our policy standards that are based on, these definitions, or does it meet like, ADA compliance, that kind of thing. And each one of those agents can actually run and check those different things as a self-contained unit individually.
That gets at Sam's question as well. They had a question about the like web content and accessibility guidelines. So that's as you mentioned, you can set up skills and checks within your AI tools so that when you do an audit of your final product, you can have it scan for things like that, as well as security and basically the aspects that you would want to check. You can just at least give a first pass of those off to an agent.
Yeah, no, that's another good question. So like you can definitely have set either skills or you can have independent agents. And so like one of the things for like larger packages that you can build, um, you can do it's called orchestrating. And so you can have an orchestrator uh, AI agent that oversees other agents that release to do very specific things. And so, like I was saying about like a security audit. So let's say your code you're worried about, some prompt injecting, getting into your code. So you can have a security agent run. You tell it, okay, this agent I needed to run and look for any security leakhole, like loopholes in here to try to avoid where that might be, and then things where um, like those ADA compliance issues too. So any of those types of things, you can have it run independent agents with those sole tasks to run through and check that code for you and verify. And then of course, everything like I said before, you have to always manually verify and double check everything yourself to know. Because sometimes one thing will break another. Like you might run the security agent, but it breaks your ADA agent's work. So that's the type of thing sometimes overlap between agents can get wrong and the balance between them of like you have to be the one to like know what you're checking and things like that.
Yeah, and for just sort of general everyday products, if you have skills for, say, branding for your institution, which is something that's very convenient, like this is the color palette of my agency, these are the approved logos, this is the approved, you know, uh, text on the final slide, things like that. You could basically feed it an empty deck or something from your agency and then create a skill off of that. And in that skill, you can ask it to monitor for ADA compliance or visual, making sure that it works for, folks with color blindness. That there's a lot of different things you can sort of layer on top of those just to get a kind of base skill that you can apply to a lot of different things. And one thing that I have noticed in my own exploration in this, like how do you use agents to tune up your code and in line with some of the things Jason mentioned, is they're kind of colloquially called foot guns, like guns you shoot yourself in the foot with, where you end up with pieces of code that behave exactly as intended, but they don't have the proper like safety guards for humans in some ways that like the code will run and execute totally properly, do exactly what it's supposed to do. But if you run things out of order, or if you're looking across multiple files, you may have something that accidentally overwrites a baseline data set that you don't want to overwrite. Or so you have to sort of follow the logic of the various saves and things throughout your code and make sure that it's not either, kind of if you trigger something manually instead of as part of an automated script or pipeline, is it going to cause a problem that really bites you later? So that's just a kind of general word of caution on top of the things that Jason mentioned, that it's good to look for those deeper logic issues yourself, or frankly code an agent to have it go out and sweep for that. Because that's something that it's quite good at, as well as uncovering those almost problems. Let's see, questions from Dagan. Do you want to unmute and ask?
Sure, maybe I can be better at actually trying to speak it versus type it. I really appreciate this conversation here. I guess I'm just trying to give some questions because I think many of us work in our state or governmental agencies where some of these steps to even get approval processes with our um, Department of IT support, as well as our called ISPO, our security office, that they have to go through very rigorous steps, and they're very strong about this, not only say within a department level, but it's at a higher level in the state. And I was kind of curious to hear how the process worked within your organization to allow use for this work, and then basically potentially because maybe some of this hadn't been done, and you're just showing the feasibility of it too, and the utility, even trying to get that done as well. Again, following better security practices with the dummy data, in many other components. But I mean, just even things like what files do they have access to with these AI agents? I mean, there's a whole host of questions that come to us when we think about or proposing that with our folks to utilize.
No, those are all great questions. And so it's definitely, it's like you said, more of it. It's more of like the general feasibility structure of where things are going towards, and then a lot of the tools and things that vendors work through that actually like come on board that different the demonstration, various things like that. The IT likes to see some of the those capabilities and things, and so we have all the same restrictions and things like that as well. It's more of the using knowing that it's not actually connecting to like a contained element thing. That's where the key different the thing is. And so like some of the um the structure of it is we have several agencies that have different uh beginning to roll out a variety of the governance committee, the data modernization directives and things like that, and working on discussing the components, and really using like this form as well from a lot of the policies that collective over multiple states from a iterative process of like, well, what can we work towards knowing that um, these tools are here that are coming, and how can we do this for agencies to support that? And so like we have a recent one that is just coming out here locally, and so we're getting with some of the tools that are processing as well, um, and it's just be able to show those demonstrations of like again understanding the key of because we see all the scary stuff in the news a lot of times. It's like, okay, this agent went released and did all these things, and it's like, if we have, of course, as the stewards of public health, many times know more importantly about our data than a lot of others in terms of organization. And so that's where we kind of have to be those thought leaders and demonstrate, even with those the fake data sets and things like that to illustrate where things are. That and they can be based on those confinements and within that framework. Um, so I hope that helps in terms of making sense. But yeah, and again, every organization is different from all that, and so it's related around where what you're operating into, what you can do, but also knowing that again, because if you have a lot of organizations that have IT structure that okay, we're going to work with this vendor, but and they just have the tools, but it's not set up. I mean, is it set up in this secure environment? Can you set a secure enclave, with the trusted execution environment within like a GPU cluster? Yes, you can. And so like those types of things that you can do in cloud environments and things like that, it just depends on the nature of the setup and where where you have it and what you can do from capability wise. And things like that. And again, like all of the larger organizations as well with I see them doing ASTO, CST, those are things are all putting out larger scale guidance to try to help improve the process overall.
Yeah, and just to kind of add to that, Megan, if you're having challenges figuring out how to communicate across teams and the sort of silos that emerge within your institution, feel free to reach out. Like that's a common question that comes up, and it's a challenge for all of us in various ways. So, I dropped a link to the ASTO AI and Public Health Resource Library. They've done a great job of aggregating some things, including some of the policies that we put together in this community over the last year or so. It can be, if you need to show where it's been done well, that's a good way to do it. And sometimes just having those conversations facilitated is a way to, um, you know, find alignment and figure out what actually works within your stack.
Yeah, I was just reading Jeff Miller's comment about his use of it. That's I mean other people have done that too. Like you use it to demonstrate like pictures, PowerPoint decks. Do you want to take comment on mute to actually tell us your how it worked?
Yeah, so I'm just sort of trying to frame my thoughts here. I actually started with an analysis, and it did a decent job at the analysis. And then I said, okay, well, now that I have this, I want to be able to take these results and then style it according to my organization's requirements. And I've tried similar things in the past. Quarto actually has a PowerPoint output that I always struggle with. I can't seem to get the styling quite right. And so I tried it again. This happened to be with OpenAI Codex Sol 5.6. So threw the big guns at it, and took a different approach, um, having it analyze the PowerPoint deck first. I, I wound up learning that PPTX files are actually zip files. So a lot of the images, if you change it to a .zip, you can extract the file, and the contents within it. And it analyzed it. Of course, I think my microphone just died. And then was able to create a workflow around that, for multiple different types of outputs. Worked pretty good. I then wound up asking it to create a skill. Of course, I had done this in VS Code in a workspace that was specific to the analysis that I started with. So then there was the question of, okay, well, I'm creating this as a skill. I want this skill to be versioned, in its own workspace. How do I extract what I've done here, generalize it, put it into its own dedicated workspace, and create a skill so that I can roll with it and iterate on it in the future? Over.
Very cool. I maybe we could do a future session on actually creating branding and like how to create a good document prep pipeline. It's a neat real time saving feature. I really just like fidgeting around with all the formatting in PowerPoint. I want to go back to a question that Ian Painter asked. Ian, do you want to unmute and ask that again?
Yeah, sure. I'm just thinking the recent experience where, I asked a high-level ChatGPT model to search up something from the web and it simply didn't do it, you know. And so I worry about if you're using AI to drive the orchestration, for key aspects, you're not necessarily guaranteed that it's going to do what you ask it to do, and it may lie about it. So the example would be if you wanted it to check, run security checks and for some reason it decides it doesn't want to do it. I mean, or for some reason it's not going to do it. It may not do it, but it also may say that it did it. Um, so the question is like kind of at what stage do you want to rely on AI for that, you know, top level orchestration or at what stage do you kind of build that orchestration yourself?
Yeah, you just don't
Right. Yeah,
ask it on a
that's
Friday afternoon because it's like done.
That's what it feels like sometimes.
yeah, that's why I didn't specifically mention like vibe coding, but like because in my mind, vibe coding is like, okay, we're just going to launch it, throw it out there, and see what happens, kind of thing. And then it's really where you have to iterate, like start and from a building process. So like just as example, like build the first framework. Like, okay, you can see, I'll just give you an example of the Shiny dashboard. Like, let me show the Shiny dashboard. Here's the tabs. Here's the filters. It doesn't have everything in it. Then okay, well, I want to add a time series chart. Okay, I want to add a bar graph. And just go from there, and you can kind of see, or have it. If you're having it do each of those things, um, build the more complex you give it up to a point, it's still that it will likely miss some of those things, like you're saying, and that's where you have to, um, you're gonna have to know some of the background of around like security piece, and that may be where you also have somebody else review it too that is more capable than, if your background's not in it, then it's maybe where you have other people do the code review and that type of thing, for you, with you, but and it's also that's another thing too, where you can work when partner with your IT. Being from more the analyst and epi side of things, doing the data, that's where you partner with them so that it's in. You have a secure firewall. You have all the actual like structural organizational pieces that are there to help secure that for you. So that's it's kind of a balance. I think is really long term, is that we kind of have to do it collectively until it gets to the point where we can trust them more than the level of scrutiny that we really have to give them still. And it may never be, and maybe I don't know, that's a kind of a long-term philosophical where that actually runs into, but But yeah, that goes back to that the hallucinated logic that we have to really think through and know that yes, it looks clean, yes, the actual results outputting, but it's still the numbers are wrong. And we actually had an example use case like during FIFA, we were doing a run on one that we were testing on, and it did the very same thing. And it was like we knew the numbers were wrong, but it was doing, but no errors were throwing, and everything was doing. So we had to like go in and dig deep to really look through to make sure where stuff was going wrong to fix it. So that's a great example of why it's critical to evaluate that and think through all those things for sure.
And
And that's kind of a good thing for folks who are doing evaluations of proofs of concept, especially if you're applying for the Pulse applications through Chai, which are due tomorrow, don't forget. Um, as you think about how these things impact your workflows, they may make some things much faster and much easier. Like there's really not a lot of um, deep diving to find errors in your PowerPoint decks branding that you need to deal with. But as Ian and Jason are just now discussing, how do you identify the logic hallucinations that are like deeply rooted down in your code? Like that, it takes the human effort from just like generating the code and just troubleshooting the actual syntax into uh, troubleshooting the entire system or structure that you're building for your work. And it's a different skill set and it requires kind of a different level of effort. But if you're looking for, to capture return on investment or hours saved, hours spent, those types of things, you have to kind of be a little bit clear-eyed that, if you write code that would have taken you 10 hours previously and half an hour, but then it takes you 6 hours of, deep um, searching for issues or, you have to balance it, right? So like where's the tipping point for like, is this truly a benefit to use on this project, or is it better if I just do it myself because I understand it from the jump rather than having to kind of go back into it. So I think planning is a really strong way to do that. And I tend to stage my work with AI in very small chunks so I can verify what it's doing, because if I just say run wild, I'm gonna ship it. Like, I can't vibe code like that. But if you break it down into very small chunks within bigger aspects of the work, it's a little more manageable to check, but it still will serve up some funny stuff in the audit.
Yeah,
You're
modular work. Yeah, I was gonna say modular workflows, like modular sections, is very effective. You can build out pieces, and then you know at what point it's doing, and so then some things won't touch the other areas as well. And so I put a link in the chat for several links. One is so for some of those that are talking about the other government capacities and things like that, the government technology, the article that says the GovTech one, that one gives a bunch of different use cases that are currently existing in a variety of government organizations. So a lot of ITs they actually host a bunch of like mini conferences and webinars and things like that, and so a lot of IT people are there, and so those you can get ideas and things like that for those that may need other use cases and type things. Then the link below it is the Shiny Assistant, which also helps build dashboards. So that kind of like into that framework that they've got out. Claude Code for anybody that's never used the Agentic components there. And then the other two that I listed, like OpenAI's Codex. And then learning R for those that are newer individual ones, like the EPR handbook is one that a lot of epidemiologists use a lot for various specific public health use cases for understanding like actually analysis to go and like check with some of those data of like, okay, am I deduplicating, iterating, the different statistical tests, that kind of thing.
Yep. And we're fortunate to have Rachel Dempsey from Posit on today to add a few extra resources in here for us. A Quarto workshop on August 12th, and a GitHub guide to using the brand YML as well. Rachel, anything you want to add to that?
No, thank you so much for the feedback too, and thank you, Jason, for the great presentation. I'm sure Emil, who's leading that Quarto workshop, would love to hear from you all too. He's like all about the slide crafting and Quarto to presentations as well. One other thing I thought might be a helpful link to share for people who are just getting started is they just recently revamped the Posit Academy page, and there's a lot of free training on there too, and like free courses. Um, it's it's new as of like the last month or so, so I haven't really played around with it too much, but I just want to share the link for you all.
Great. Thanks very much for that. We'll make sure that gets out as well, so that folks hear about it, even if they weren't able to be in this session. Any other questions for Jason?
I'm going to share one more specific one instead of just sending you to the Academy page. I just found one that's specifically an introduction to Shiny. So I think that would be a good one.
Excellent. Yeah. Get those intro classes if you haven't used Shiny much at all. So we're about at time, but we will be excited to see you all back here again on August 20th. We're going to be talking about the intersection of Fire and HL7 and AI. So interoperability, real life challenges and use cases from Phenomenal and Carrie Weinberg. So she does training for the HL7 Institute for AI and all of this. So she comes from a deep background in data exchange and interoperability. So if that's your jam and you love messaging more than anything, come on down because we'll have lots to say about it. So we'll see you back on the 20th and take care, everybody. Thanks for joining today. And thank you, Jason and Rachel, for being here.